Okay, so now I'm going to do a whole bunch of mole ratio problems, a whole bunch, so you can really get a handle on these. They're super important for stoichiometry, for understanding stoichiometry. Okay, each problem I'm going to do it two ways. First, I'm going to treat the equation, the chemical equation, kind of like a recipe, all right, where we've got our ingredients and then we've got the stuff we're baking. This method really makes sense, like you'll understand what you're doing, but it requires a little bit of thought. Then, I'll solve each problem using a conversion factor method. The conversion factor method doesn't require any thought, but it doesn't make any sense. So it's really easy to get in the habit of only using the conversion factors, running through the math, but having absolutely no idea what you're actually doing or why you're doing it. Okay, so that's why I'm going to do each of these problems two different ways. Okay, so let's get started. Here is the first equation I'm going to be working with. 2 moles of H2O, water, makes 2 moles of hydrogen gas and oxygen here. If there's no coefficient in front of the oxygen, in front of one of these chemicals, we know that it's really 1, that it means 1 mole. So hey, if it helps you, go ahead and write that 1 in. There's our equation. Here is the question. How many moles of O2, of oxygen, will be produced from 6.2 moles of water? Okay, so first of all, I want you to think of this like a recipe. And right now, it's saying that we start with 2 moles of this, and that gives us 2 moles of this and 1 mole of this. But we're not talking about starting with 2 moles of H2O. We're talking about starting with 6.2 moles of H2O, okay? So this is just like when you're cooking, and you've got a double or triple or quadruple recipe. What do we have to do to this recipe so that instead of starting with 2 moles of water, we start with 6.2 moles of water, okay? We have to multiply everything in this equation by something that's going to get us 6.2 moles of water. We can figure this out a couple ways. First thing that I can do is I can do 6.2, which is this, divided by 2, which is that, and that gives me 3.1, okay? That gives me the factor. And what I mean by that is that we take each one of these numbers and we multiply it times 3.1. 2 times 3.1, and now we get 6.2 moles of this, okay? So now we're starting with 6.2 instead of 2. We multiply this by 3.1. Now, we'll also want to multiply the number of H2 times 3.1. So now we're getting 6.2 moles of H2. And we want to take this number, which is 1 times 3.1, multiply it there, and we get 3.1 moles of O2. So once again, we treat this like a recipe in the kitchen that we're doubling or tripling. Instead of multiplying by 2 or by 3 or by 4, we multiply everything in this recipe by 3.1, and we get 6.2 here, so that's what we're starting with. Then we get 6.2 moles of H2, and we get 3.1 moles of O2. And that kind of makes sense, right? Because there's this 2 to 1 ratio of water to oxygen. We start with 2 of these, we get 1 of these. So this is half of what we have here. Okay? So if we start with 6.2, we multiply everything by 3.1, and we get 6.2 here, and this 3.1 is half of what we had over here. Okay? So that's how we can do this equation, treating it like a recipe in the kitchen. Now let's look at how we can do this using conversion factors. Okay? What we're going to do is we're going to start with 6.2 moles of H2O. Now what I want to do is I want to write a conversion factor that tells me the relationship between the moles of water and the moles of oxygen. Okay? We can sum it up with this. It tells us for every 2 moles of H2O, I get 1 mole of O2. 2 here, 1 here. Okay? We get this relationship. And what I can do is I can use this to write a conversion factor. There are 2 different conversion factors I can get from this. I can write 2 moles of H2O over 1 mole of O2. Okay, that's 1. Or I can flip it. I can do 1 mole of O2 over 2 moles of H2O. Of course, I'm just getting the numbers from the chemical equation here, 2 and 1. So I've got these 2 conversion factors that are flips. I could use either one of them. They're both equally good. The one that I want to choose, though, is the one that I can multiply by this and cancel out moles of H2O. Okay? That's going to be the one that has H2O on the bottom, because it's on the top over here. So I'm not going to use this one. I am going to use this one. I'm going to multiply it here. And now I have H2O on the top, H2O on the bottom, so they cancel out. And when I do this math, I'm going to do 6.2 times 1 divided by 2 equals 3.1 moles of O2. And check it out. I use a conversion factor method, and I get the exact same answer that I got when I use this like a recipe. Okay? So the recipe or the conversion factor both give the same number. Okay? Let's go on to the next one. Okay, so how many moles of H2O will be required to make 19.2 moles of O2? Let's treat this like a recipe first, okay? Right now, this is a recipe for 1 mole of O2. What are we going to have to do to this recipe? Double it, triple it, quadruple it is what I mean. What are we going to have to do to this recipe to make it a recipe for 19.2 moles of O2? Well, there's a 1 right here. 1 mole of O2 in the recipe. So it shouldn't come as a shock that we have to multiply the recipe by 19.2. And now, if we multiply by 19.2, it will become a recipe for 19.2 O2 times 19.2. And this is going to give me 38.4 moles of H2. Multiply this by 19.2, because just like when you're cooking, right, you got to multiply everything in the recipe by the same number. And this is going to give us 38.4 moles of H2O. This is what happens to the recipe when we size it up to cook for 19.2 moles of O2. So the answer is, how many moles of H2O are we going to need? We're going to need 38.4 moles of H2O. That's the recipe method. Okay? Now let's look at the conversion factor method. Just as before, we realized that the relationship between water and oxygen, by using the chemical equation here, is 2 of these to 1 to these. So we can get these 2 conversion factors. We have 1 mole of O2 to 2 moles of H2O, or 2 moles of H2O to 1 mole of O2. I'm going to start here with 19.2 moles of O2, and I want to be able to multiply this by the conversion factor that's going to cancel out my moles of O2. So I'm going to choose this one here, because it has moles of O2 on the bottom. cancel out, cancel out. I do 19.2 times 2 divided by 1 equals 38.4 moles of H2O. I know it's moles of H2O because that's the unit that I have remaining, okay? So sometimes people ask, why are you doing it both ways? Why are you doing it the recipe way and then the conversion factor way, okay? The reason is because, for me, the recipe way makes a lot more sense, but teachers and textbooks are in love with conversion factors. They love them. They can't get enough. I don't think that conversion factors make any sense at all right? But just because they're like commonly used, your teacher's going to ask you to do it, your textbook's going to ask you to do it, that's why I'm doing them too. But what I want you to focus on is actually why we're doing it, the way we multiply things and get the answers here with pretending it's a recipe. I want you to focus on this so you understand what's going on. And as you can always see, the answer that we get from the conversion factor method is the same as the answer that we get when we're treating it like a recipe and multiplying everything by some number, okay? All right, let's move on to the next question. So, 2 moles of H2S, hydrogen sulfide, combined with 3 moles of O2, oxygen, to make 2 moles of SO2 and 2 moles of H2O. Using this equation, we're asked how many moles of O2 are needed to combine with 8.4 moles of H2S, okay? What do we have to do with our recipe to cook with 8.4 moles of H2S instead of 2 moles of H2S? What we're going to want to do is we're going to multiply this by some number that's going to give us 8.4. How can we figure out what that is? Well, you might sort of be able to do it in your head. Or you can do 8.4 divided by 2, and that's going to give us 4.2. So 4.2 is the number that we're going to have to multiply everything by so that we can move from 2 moles of this to a recipe that uses 8.4 moles of this. Okay, so everything, we're going to multiply it by 4.2. Okay, so here we have 3 times 4.2, and that's going to give us 12.6 moles of O2. 2 to 3, 8.4 to 12.6. All right, let's see how we can do this using conversion factors. We'll start with 8.4 moles of H2S and multiply that by one of these two conversion factors. These conversion factors are just telling us the relationship that we have here of 2 moles of H2S to 3 moles of O2. And I can use this relationship to make these two conversion factors. Which one do I want to use? I want to use the one that has H2S on the bottom so that it cancels out. So I choose this one. Cancels out, and this is going to give me, what a shocker, 12.6 moles of O2. Why moles of O2? Because it's the unit that's left here. Okay, that's how we can do it, treating it like a recipe. Here's how we can do it using the